Unit 4, Lesson 1. This lesson aligns with 6.6 in your textbook. In this lesson, we're going to be dealing with coordinate proofs. So we're going to plot some ordered pairs and then create a shape on the coordinate plane. And then we're going to prove what shape that is based on the properties that we see. For instance, if we thought it was a square, we would have to prove and verify that all four sides are the same length and we have four right angles. A few formulas we're going to use in this lesson. The distance formula, d is equal to the square root of the difference of our y value squared plus the difference of our x value squared. Slope is equal to y2 minus y1 over x2 minus x1. And then we're also going to talk about circles at the end of the lesson. The basic equation for a circle is x minus h quantity squared plus y minus k quantity squared equal to r squared. The ordered pair HK, that represents the center of the circle, and the radius is represented by R. In this first example, use the given points to plot the figure, and then prove the special quadrilateral that is formed. Okay, looking at this, it appears that the side lengths might all be congruent to each other. So that could be a rhombus or a square. So we need to find the length of each of these sides. So we have to use the distance formula 4 different times. So using the distance formula 4 times, we find the lengths of AB, BC, CD, and AD. If simplifying, we get radical 50 for all of those. So we verified that all four sides are congruent. So now we know this quadrilateral must either be a rhombus or a square. So now we have to show whether or not two adjacent sides form a 90-degree angle. So we can do that by comparing the slopes. The slope of AB would simplify down to 1/7, and the slope of BC simplifies down to -1. So comparing those, we can see those are not opposite reciprocals, which verifies that these two sides are not perpendicular, thus this is not a right angle. So the last thing you need to do is state the most specific name for the shape that you have. In this case, it's a rhombus. And then you also need to specify which properties you showed or proved to verify that this was a rhombus. In this case, we proved there's 4 congruent sides, and then we also proved that there's not 4 right angles. Even though we only proved one angle, that's all we need because we proved that one angle was not a right angle, thus it doesn't meet the condition needed for it to be a square. This next example, very similar. We have the 4 ordered pairs for A, B, C, and D. If we plot those ordered pairs and connect those points, we can see we have a quadrilateral, and it appears to be a trapezoid. So now we have to go through, think about what properties we know about a trapezoid. Well, our main property we've discussed, you have exactly one pair of opposite sides parallel. So we're going to have to deal with the slopes of all 4 sides and show there's only one set that is parallel to each other. And then we also have to verify whether or not this is an isosceles trapezoid. Isosceles trapezoid is a trapezoid where the 2 legs are congruent to each other. So then we're going to have to find the distance of AB and CD and verify whether or not those are congruent to each other. So first thing, we find the slope of all 4 sides. So the slope of AB simplifies down to 4, slope of BC is 1/3, the slope of CD is -3/2, and the slope of AD is 1/3. So looking, we have 2 sides opposite that have the same slope, implying that they are parallel, and the other 2 sides have different slopes, so they are not parallel to each other. So this shows that we have a trapezoid. Now we have to go and use the distance formula to determine if this is isosceles. Finding the distance of the 2 legs AB and CD, we find the length of AB is radical 17 and the length of CD is radical 13. So the 2 legs are not congruent to each other, so this is not isosceles. So when we're trying to determine what shape it is, the special quadrilateral, it is a trapezoid. And we specify the properties that we proved, one set of parallel sides, and then the legs are not congruent. To end this lesson, we're going to talk about equations of circles. So we want to use the given information to prove whether the point lies on the circle. So the information we have, the center of the circle is at 2, 3, and the radius is 5. We want to prove whether or not the point -1, 7 lies on the graph of this circle. First thing we need to do is to take this information, the center and the radius, and create an equation for this circle. So the equation was x minus h quantity squared plus y minus k quantity squared equal to r squared. So plug these values in, we get x minus 2 quantity squared plus y minus 3 quantity squared equal to the radius squared, so 5 squared. So here's the equation for our circle. Now we have to take these points, plug this in for x, plug this value in for y, determine if it gives us a true statement. Thus we get -1 minus 2 quantity squared plus 7 minus 3 squared equal to 5 squared. Simplifying that, -3 squared plus 4 squared equal to 25. -3 squared is 9 plus 4 squared is 16 equal to 25. Thus we get a statement that is true. So this is an algebraic proof verifying that the ordered pair -1, 7 would lie on the graph of the given circle.